Okay, so hello. This is my Physics Lab 3 video report for the bar magnet lab, and I've been struggling with audio problems, so I hope you can hear me.
The introduction. The purpose of this lab was to observe and better understand magnetic fields through visual representation, to visually observe the relationship between distance and magnetic field, and to use the distance dependence of magnetic fields in the Biot-Savart law to find the magnetic moment of a bar magnet. The fundamentals of this lab: we're using a bar magnet to model a magnetic dipole, using the Biot-Savart law, and using the distance dependence formula of a bar magnet, which are shown. The results of this lab were that the magnetic moment of the bar magnet was 2.21 amperes times meters squared, and n equals negative 2.50. For the assumptions and models, we assume that the bar magnet acted as a magnetic dipole in order to apply the Biot-Savart law. For the experiment itself, the system was the bar magnet while the surroundings were everything else, and the initial conditions were the bar magnet and the magnetometer on the phone. For the details of the experiment, I first found the location of the magnetometer on the phone by sliding the phone perpendicularly to the axis that the ruler was on, both vertically then horizontally, with the bar magnet on one end of the ruler, in order to see at which position of the phone relative to the magnet the strongest magnetic field was being read. I then placed a piece of tape at that location in order to pinpoint the exact location. Then we moved on to the main experiment. First, we had to orient the phone so that the x component of the magnetic field was 0, ensuring that the Earth's magnetic field did not interfere at all with our reading for the on-axis magnetic field of the bar magnet. Then the on-axis distance from the bar magnet to the magnetometer was found using the ruler for several different magnet field values. These values were then linearized by taking the natural log of each side and then graphed. For part 2 of the experiment, we found the off-axis magnetic field of the bar magnet. We did so by first finding the on-axis distance from the bar magnet to the phone such that the net magnetic field was 100 microteslas. Then we slid the phone in the vertical direction the same distance and recorded each component of the net magnetic field at this location. The y component of the magnetic field due to the bar magnet was found by subtracting the Earth's contribution to the y component of the magnetic field from the total y component of the magnetic field at this location. Observations that I made during the experiment were that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. As the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases, and that the position of the phone matters in terms of ensuring that the magnetic field of the Earth doesn't interfere with our readings for the magnetic field of the bar magnet. Now moving on to the calculations, I found that the distance dependence equation of the graph was y equals negative 3.043x minus 14.633. As you can see by the linearized equation to the right, n is the